everybody did. Everybody in their drawings and schematics for the building did made everything compatible with 65 volt DC power, except the fellows that built the oxygen tanks and putting the heater system in that tank to chirp the tank with a little fan and to heat the liquid oxygen just a little bit to pressurize it into a gas, to pressurize the spacecraft for breathing and for using that oxygen as part of our fuel cells. We use oxygen and hydrogen. The little thermostat at the top of that tank that was supposed to check that or protect that tank from overheating was only compatible with 28 volt DC power. No one ever caught it. On the first flights to the moon, all the way through Apollo 12, including Neil's Apollo 11 and everything, we never used the heater system long enough for the little thermostats to open up with a 28 volt thermostat to shut off the power. So it was an anomaly that kept on going through. But then on 13, and for those of you who might be in the aviation business, most aviation accidents are caused by not just one malfunction, but a series of malfunctions that usually overcome the pilot and or the airplane. The second thing that happened for 13 was as the tank was being manufactured, it was dropped at the factory. Not hard, but they picked it up, and it was scheduled for Apollo 10. And they completely refurbished it. They did everything to make sure that the tank would produce, you know, liquid oxygen to all the systems. They erased on the tank the chalk line that said Apollo 10 and put Apollo 13 on. Then the tank was, of course, joined with the rest of the spacecraft. And about 2 weeks before the space flight, before launch, everything's in place. We did what was known as a countdown demonstration test. The crew gets into the spacecraft. We fill up the spacecraft itself with all the fluids, the consumables, liquid oxygen, liquid hydrogen. We don't put anything in the booster itself. It's empty. But all the supporting people out on the launch control center, they're out there. And we count down the launch all the way down to 0. We want to make sure that everybody knows what they're doing. We want to make sure that the spacecraft gets fired up and all the systems of the spacecraft are working so that we're all set to go for launch. Perfect countdown demonstration test. Crew left the spacecraft. Everybody else packed up their bags except the people that were supposed to, or who were going to secure the spacecraft. What they had to do was, of course, remove the consumables. And so when they got to the oxygen tanks, they took a gaseous oxygen hose, put it into the fill line, and then forced gas into where this liquid, you have to remember this liquid is 240, 250 degrees below 0, and force it out the vent line. That's the normal way that you detank an oxygen tank on one of these tests. On the first tank, it worked fine, no problem with that. They went over to the second tank, and the spacecraft had 2 tanks. And when they put the hose in and they forced gaseous oxygen in, out of the vent line was coming gaseous oxygen, no liquid. This is strange, never happened before. Well, like all good engineers, they said, well, there's something wrong here. So they went down to the engineering spaces, and they put out the schematics of these tanks to find out what the story was, and also they looked up the history of this tank. Oh, it's been dropped at the factory. And then they looked at the schematics, and there was a little tube in these tanks whose sole job was to take the liquid, and when the gaseous oxygen came in, and force the liquid out. And if it had been jarred and out of place, then the symptoms that they were now seeing would happen. Well, they said this must have happened. Everything else was fine. The tank itself works perfect for a flight to the moon. I mean, it will feed everything that it has to feed. And the only time we used that little tube anyway was to detank it on a test. And then they started to philosophize. They said, well, we could replace that tank, of course, but it would take a month to go through all the tests again, put it back in there, and delay the launch at least a month. And they said, well, we have a heater system in that tank. Why don't we turn on the heater system and boil the oxygen up? And then we could fill it up, and everything would work fine during flight. So they said, that's not a bad idea. They checked the contractors, they checked the NASA people, and they even talked to us about it. We said, that sounds like a good idea. So they turned on the heater system. Now there was two ways to check what the temperature in that tank. On the gantry by the spacecraft itself, there was a temperature gauge that would record the temperature inside those tanks. That gauge was calibrated to plus 80 and a minus 250. Of course, as you know, liquid oxygen is pretty cold. And in the engineering spaces, there was a little sort of a little stylus that would tell when the power was on and when the power went off. Because when they turned on the heater system, as the oxygen went down in the tank and the upper part got warmer, they wanted to make sure that the thermostat was going to open up and shut the power off. So they turned on the heater system. They kept it on for 8 hours. As advertised, just as they expected, all the oxygen went out. Nothing wrong, everything went fine, and so everything was good. What they didn't know was as the oxygen went down towards the bottom, the upper part of the tank got warmer. And the little thermostat, only calibrated for 28-volt power, started to open up when the temperature up in that upper part of the tank got to around 80 degrees Fahrenheit. At 80 degrees, it started to open up. But the higher power, the 65 volt that we were using, welded the little contact shut. No one caught it. No one ever looked at the stylus in the engineering compartment to see that the thermostat had shut the power off, and then as it cooled off, would turn it back on again. It stayed on that piece of paper for the total 8 hours. It removed all the oxygen, but also damaged the heater system itself, which is covered by a Teflon sheet of some sort. And when we put oxygen into the tank just the day before launch, it was a bomb ready to go off. It completely destroyed all the heater system itself that no one ever thought. It took off, I think 2 times out of the way to the moon. We had to turn on the heater system a little bit to boil up oxygen. Nothing happened. And then on the 3rd time, about 200,000 miles out, when we flipped the heater switch on, the Teflon caught fire, a spark or something like that, inside the tank. And as the fire grew in the tank itself, the pressure blew the neck off that tank, releasing all the liquid oxygen into the bay, and the bays were vented to a vacuum. And so as soon as the liquid hit into a vacuum, it flashed into a gas and blew the entire side of the spacecraft off. That was the explosion we heard, not the first one. And what the catastrophic thing was, it damaged the second tank, damaged either the valve or something causing a leak. And so when the first explosion occurred, it happened right away, and when I looked out the window and saw something escaping from the spacecraft, it was oxygen from the second and our last tank, some 200,000 miles out. Now, there is a little bit of fate in this whole flight. When we first turned on the heater system, just after we committed ourselves at a very high velocity to go to the moon, and it blew. We would never have had enough electrical power in the lunar module or anything else to go all the way around the moon and come back again. We've been lost. If this thing had not blown at the time we put the switch at all, it had blew once we were in lunar orbit or we were on the surface, we had never had enough fuel in the lunar module to get out of lunar orbit to come back, and we would have been lost. So if you're going to have an explosion on the way to the moon. 200,000 miles. Thank you, ladies and gentlemen.